You know, people sometimes ask me when I decided to become a physicist, as if there was a day I woke up and said, well, that's it, I'll go into physics. But it wasn't like that at all. I never made a decision like that. I was just curious, that's all. And I never really stopped being curious. When I was a kid growing up in Far Rockaway, my father used to take me for walks. He wasn't a scientist or anything like that. He worked in sales, but he had a way of looking at things that stuck with me. We'd be walking along and he'd point at a bird and say, you see that bird? In Italian it's called this, in French it's called that, in German something else. And then he'd look at me and say, now you know what the bird is called in 3 languages. But you don't know anything about the bird. That bothered me in a good way, because he was right. The name didn't tell you why it twitched its head the way it did. It didn't tell you why it kept pecking at its feathers. He'd say, watch it. What's it doing? And we'd stand there just watching. He'd explain how there were little parasites living in the feathers, eating protein, and the bird had to clean them off. Suddenly the bird wasn't just a name. It was a system, things living on other things, causes and effects, a little world moving around for its own reasons. That was much more interesting than the word for it. Another time, he pulled a wagon with a ball sitting inside it. When he jerked the wagon forward, the ball rolled backward. I must have been 5 or 6, and I remember staring at that like it was a magic trick. He didn't say inertia. He didn't say Newton's first law. He just asked me, why do you think it does that? And we'd talk it through. If the wagon moves forward suddenly, the ball doesn't know it's supposed to go with it. It just keeps doing what it was doing. That idea that things don't change their motion unless something makes them felt almost mischievous. Like nature had rules, but they weren't written down anywhere. You had to notice them. At home, I started building little things, radios, mostly. During the Depression, if your radio broke, you didn't rush out and buy another one. So I'd take them apart and fix them. People thought I was some kind of wizard, but I wasn't. I just knew that the signal had to come in somewhere, pass through tubes, get amplified, and come out as sound. If it wasn't working, something along that path had to be wrong. That's all. It wasn't magic. It was reasoning. And I liked that feeling, that if you thought carefully enough, the world would give up its secrets, not because it wanted to, but because it had to. Of course, I didn't think of it that way at the time. I wasn't walking around saying, ah yes, I am uncovering the deterministic structure of physical law. I was just a kid who didn't like not understanding things. In school, I noticed something funny. The other kids were very concerned with getting the right answer. They wanted the formula. They wanted the method the teacher used. I wanted to know why the method worked. Sometimes that made me slower, sometimes faster. If I could see why something worked, I didn't have to memorize it. I could rebuild it any time. I remember teaching myself algebra before it was officially taught in class. I'd get these books and work through the problems just because they were puzzles. It wasn't discipline, it was entertainment. You had an unknown X, and you had to chase it down. It felt like detective work. But even then, I noticed something that bothered me. You could follow the rules perfectly and still not understand what you were doing. You could move symbols around like little chess pieces and never once ask what they represented. That seemed backwards to me. The symbols were supposed to stand for something real. So whenever I learned something new, I tried to turn it into a picture in my head. If we were talking about motion, I imagined an object sliding on ice. If it was electricity, I pictured little charges pushing and pulling each other. I didn't care if the picture was perfect. I just needed something I could hold on to. By the time I got to high school, mathematics became more serious. Calculus showed up. Now we were talking about limits and derivatives, things that sounded very sophisticated. But I refused to treat them as magic. A derivative to me was just a way of asking, how fast is this changing right now? Not over a long stretch, not on average, right now. If I couldn't connect it to motion, to something moving or growing, then it felt empty. I think that's when I really started falling in love with physics. Not because it was grand or mysterious, but because it was honest. It didn't care what you believed. It didn't care what words you used. If you dropped something, it fell. If you pushed something, it accelerated. The rules were there, whether you liked them or not, and the best part was you could test them yourself. I didn't have a grand laboratory. I had a bedroom and a few tools and a lot of questions, but that was enough. If I wondered how a circuit behaved, I could build one. If I wondered how something moved, I could try it. There was something deeply satisfying about that, about not having to accept someone else's authority when you could check it. When I finally went off to MIT, I expected to find people who thought the same way, and I did. But I also found something else. I found brilliance, incredible mathematical ability, people who could manipulate equations faster than I could read them. And at first I felt a little uneasy, because they were very good at moving symbols, but I still wanted to know what the symbols meant. There was one particular class I remember sitting there watching the professor fill the board with equations. Beautiful equations. Clean. Compact. Everything balanced just right. And the students around me were copying them down as fast as they could, like they were collecting rare stamps. I copied them too. But I had this uneasy feeling. I'd look at an equation and think, all right, but what is happening? Not what does the equation say, what is actually going on out there in the world that this thing is describing. So I developed a habit. I'd go back to my room and take the same equation and try to re-derive it from scratch. Not because I didn't trust the professor, but because I didn't trust myself. If I couldn't get there on my own, I didn't feel like I owned it. Sometimes I'd get stuck for hours, and that was frustrating, but it was also the fun part. Because when it finally clicked, when the pieces fell into place, it wasn't just something I'd memorized, it was something I understood. I remember struggling with some problems in electromagnetism. Maxwell's equations are magnificent. Really, they are. But at first, they're just these elegant lines of symbols. So I'd sit there imagining I was a tiny charge floating in space. If another charge moved nearby, what would I feel? Would I be pushed, pulled? How quickly? From which direction? It sounds silly, maybe, imagining yourself as an electron, but it forced me to connect the mathematics to a physical experience, even if it was imaginary. Once I could feel the forces in my head, the equations made sense. They weren't abstract anymore. They were instructions for how reality behaved. And something else happened at MIT that I didn't expect. I discovered that not understanding something didn't bother me nearly as much as pretending to understand it would have. Some students seemed uncomfortable admitting confusion. They'd nod along, take notes, and move on. But I'd raise my hand and ask what felt like a simple question. Sometimes it was embarrassingly simple. But I'd rather look foolish for a minute than stay confused forever. So I began to realize that a lot of what passes for intelligence is really just fluency. Fluency with language, with symbols, with the right way to say things. But fluency isn't the same as comprehension. You can speak a sentence perfectly and still have no idea what it refers to, right? That idea had been in my mind years earlier, walking with my father, staring at birds. Now it was coming back in a different form. Only instead of birds, it was quantum mechanics and electric fields. The pattern was the same. Every time I see something new and I wanted to figure it out, that pattern came back to me in a click. If you only know the name, you don't know the thing. And I found that the only way I could stay honest with myself was to keep asking, what is this actually doing? See, keep asking questions could only open your mind, at least that's my thought. And to me, that is the true reality. By the time I was finishing at MIT, people would ask what I was going to do next. Graduate school. Naturally, that was the expected answer. For me, it did not feel like advancing towards some grand objective. It felt like continuing something that had already started years earlier. The questions were getting more complicated. The mathematics was getting heavier. The textbooks got thicker and the professors wrote faster. Still, the basic experience was the same as when I was a kid staring at a ball in a wagon. Something happens and you wonder why. Then you keep worrying at it until it gives. I knew students who were quicker with calculations. Some of them could manipulate equations like concert pianists. I was never especially impressed by speed. What mattered to me was whether the thing made sense in my head. If it did not, I could not simply file it away and move on. It would sit there in the back of my mind, tapping me on the shoulder while I tried to do something else. So I would go back to it, and then I would take it apart again. Sometimes I would discover I had misunderstood something ordinary, the sort of thing you feel silly admitting. Sometimes the confusion came from assuming too much too soon, using a word before I had a picture for it. Either way, once the picture became clear, the relief was wonderful. It felt like a knot coming undone. I also learned a practical trick. If I could not explain an idea in plain words, then I had not really digested it. So I would try to say it out loud to myself, the way I might say it to my kid sister, or to a friend who wandered into my room and asked what I was doing. If I started reaching for fancy terms, I would stop and try again. I wanted a simple story about what was happening, what pushes what changes, what stays the same. The equations could come later as a kind of shorthand. There were nights I would be sitting with a problem set, and I would get stuck on some little point that everyone else seemed to pass over. The sensible thing would have been to copy the method and move on, but I could not do it. I would stare at the page, draw little sketches in the margin, make up a physical situation that matched the symbols. I would imagine the motion, the forces, the energy moving around. Sometimes I would pace the room like that was going to help the mathematics. It did not help the mathematics, but it kept me from going cross-eyed. Then, suddenly, the thing would snap into place, not with fireworks. More like you turn a key in a lock, and it finally turns. After that, the rest of the work would go quickly, and I would wonder why it ever seemed hard. That is a funny feature of understanding. Before you have it, you cannot see it. After you have it, you cannot imagine living without it. People like to imagine that science is a steady march forward, with everyone agreeing on what things mean. In a student's head, it is more like a cluttered room. You keep bumping into furniture you forgot you had. You shove things around, you trip, then, after enough stumbling, you can finally walk across the room without bruising your shin. And I like that process. I like that the world was consistent. If you pushed on it the right way, it pushed back the same way every time. You could test an idea in your mind, then on paper, then in a laboratory, and the answer did not care about your pride. Anyway, that is how it started. There was no ceremony. I did not sit down and declare that I was dedicating myself to physics. I just found that every question led to another one, and I enjoyed chasing them down. It turned out to be a very dependable arrangement. I kept asking questions, and the universe kept answering, usually in ways that made me work for it. That seemed fair enough.